Hi, Logic students. This is a general video on Chapter 7. I just wanted to highlight the general principles for this chapter and clarify that things are not as difficult as they might seem. Essentially, in Chapter 7, you're using what are called rules of inference. And rules of inference are um, they're essentially valid arguments that are used so frequently that they got their own name, and they are referred to by those names in logic. These are not arcane or mysterious rules. They are basically rules that you use all the time. I'll give you an example. Suppose you know that a friend of yours went to the restaurant and ordered an entree, and with that entree, he could get soup or salad. So let S stand for your friend can get soup, and D stand for your friend can get salad. And you also know that he chose not to get the soup. What follows from that? Well, obviously, it follows that he got the salad. So this is a rule that we use all the time. It's come to be known as disjunctive syllogism, or DS. But, we could call it the soup or salad rule. And obviously, this works also when you have slightly more complicated situations. Say that the choices were either soup and breadsticks or salad and corn muffin or something like that. And suppose that your friend doesn't want the soup and breadsticks. What follows from that? Well, obviously, that he got the salad and the corn muffin. If there are two alternatives and one is crossed out, the other one must be the correct one. So there's nothing mysterious here. You just call it disjunctive syllogism. That sounds very complicated, but it's a rule of thinking, of thought that you use all the time. Similarly, suppose that you know that you have this very kind of precise and well-prepared friend, so you know that when it rains or if it rains, your friend always brings an umbrella. So R stands for it rains, and U for your friend brings an umbrella. And then suppose that you look out the window and you see that it's raining. What follows from that? Well, obviously that your friend will have an umbrella. This way of thinking, this rule of thought, is known as modus ponens. So whenever you have a situation where something is sufficient for something else, as in if R, then U. If it rains, then Bill will bring his umbrella. And that sufficient condition is met. The other thing follows. That's how modus ponens works, and you use this rule of thought all the time. Again, this works in more complicated situations as well. Suppose that if it rains or snows, then Bill brings his umbrella and wears a coat. And then suppose that it either rains or snows on a particular day. Obviously, what follows is that Bill will bring his umbrella and wear a coat. But the structure is the same. Again, there's a situation or a combination of events that is sufficient for something else, and then the sufficient condition is met. So the other thing follows. Let's call this the umbrella, just to remember. Here's another one that you use all the time. A lot of students don't have too much time to cook or shop, so sometimes things accumulate in the refrigerator. And maybe you'll have this bottle of milk that has been sitting in your refrigerator for a long time, and you're not sure if it's still good. So what do? You smell the milk to see if it's still good, because you know that if the milk has gone bad, then it smells. Suppose that you smell it and it doesn't smell bad. What follows? Obviously, that the milk has not gone bad. So when you have a conditional, if B then S, and then the negation of the consequent, not S, the negation of the antecedent follows. You use this rule, this way of thinking all the time to rule out certain things when something, in this case S, is necessary for something else. So smelling bad is a necessary condition for the milk to have gone bad. It will be a telltale sign that the milk has gone bad. But if that necessary condition is not present, if the milk doesn't smell, you rule out that it has gone bad. This rule is called modus tollens, and we could call it the smell the milk, just to remember. And finally, when you have two conditionals that hook up in a certain particular way, you can form a third conditional that kind of puts together the two. Here's an example. Suppose that you know that if you neglect to do the maintenance on your car, then the engine may overheat. And you also know that if the engine overheats, then you may have to make some costly repairs. What follows from that is that if you neglect to do the maintenance on your car, then you will have to make some costly repairs. So see how these two conditionals are related to each other. You can think of them as domino tiles. As when you line up some domino tiles, in order to be able to line them up, you need for there to be like the end of one tile has to be the same as the front of the other tile. If there's that hook, that point of contact, then you can put together the M and the R in this case and make a third conditional that has the antecedent of the first and the consequent of the second. So the rule here, stated generally, is if you have a conditional, P then Q, whatever P and Q may be, and you also have another conditional, if Q then R, because they hook up in that particular way, the consequent of the first is the same as the antecedent of the second. And you can infer a third conditional that has the antecedent of the first and the consequent of the second. So let's call this rule the domino. If you think of the rules this way, it'll be easier to remember them and also to be reminded that they're not mysterious and strange rules of logic, but they're principles of thought that we use all the time. So the disjunctive syllogism or the soup or salad is P or Q, not P, therefore Q. Modus ponens or the umbrella is if P, then Q, P, therefore Q. Remember that the P's and Q's can be any formulae whatsoever, simple or complex, it doesn't matter. And then smell the milk, if P, then Q, not Q, therefore not P. And the domino. Domino is if P, then Q, Q, then R, therefore if P, then R. These are the rules. And the only thing you need to remember from chapter 7 is this principle. It tells you everything you need to know. When an argument is valid, I'll just read it off here on the screen. When an argument is valid, you can prove it is valid by constructing a proof of that argument. And what is a proof? A proof is a series of steps where you go from the premises to the conclusion. When the argument is valid, you can literally go from the premises to the conclusion in a series of steps. And each step in that process will be either a soup or salad, or an umbrella, or a smell the milk, or a domino. That's the only thing you need to remember. In section 7.1, the rules are only DS, MP, MT, and HS. In section 7.2, which we also cover, 4 more rules are added. I guess the only one that will be a little bit more complex will be CD, but the other ones are very, very simple. Simplification, conjunction, and addition. But the principle is the same. The idea is that you use the rules as stepping stones in going from the premises to the conclusion. You extract the conclusion from the premises. So here are a couple of examples that should solidify all this. When you're given an argument, it will be written out with the premises on numbered lines. 1, 2, and 3 here are the premises of this argument. It's exercise 2 in part 3 of exercise 7.1. And then you will be given the conclusion, which will be written after a slash, so as to separate the conclusion from the premises. And your task is to add more steps. So you start with step 4 until you get to the point where on a new line you will enter T. Sometimes you can do this in one step if it's a very simple proof. Sometimes you'll need 2, 3, 4 steps. And if it's a very complicated proof, you may need many steps. But normally the proofs that we do require between 2 and 4 steps. That would be an average proof. So now you can look at these lines and see if you have an opportunity to do a super salad, an umbrella, a smell the milk, or a domino. And you should immediately see that if you look at lines 1 and 2, that's a super salad. The F is the soup, and D then T is the salad. Those are the 2 alternatives. And then number 2 says not F. So the soup is rejected, and the other thing is ordered. So what follows from lines 1 and 2 by super salad or disjunctive syllogism is the other element of this disjunction on line 1. So you enter into the proof if D, then T, the salad part of the super salad on line 1. And you justify this move. You have to explain why this move is legit. So you'll cite the line numbers that you used, 1 and 2, and the rule, disjunctive syllogism. Then you keep going. You do it again. You try to do it again with what you have. You can still use any of the lines. You can still use any of the rules. It's not like now that you have used DS, you cannot use it anymore. You could if there was an opportunity. But I think you probably are seeing that lines 3 and 4 go very well together as an umbrella. If D, then T. So if it rains, then Bob brings his umbrella, and then D, it is raining. So that fits the pattern of the umbrella. On line 5, you can use a modus ponens. If D, then T, together with D, entail T. Justification 3, 4, modus ponens. And you're finished because you were able to enter on a separate line by itself the conclusion of the argument. So the proof is accomplished here. Any proof that you do pretty much works in this way. The only difference might be between different proofs, might be the number of steps that you have to do, and some proofs will have slightly longer and more complicated formulae, but the idea is always the same. So let's do this other example. It's number 18, still from exercise 7.1, part 3, number 18. Again, you're given the premises. There are 4 premises, 1, 2, 3, and 4. And your task is to go to the conclusion, to extract the conclusion from the premises in a sequence of steps, and to distill the conclusion from the premises. And so you would enter 5 for your next step. And you see if you can do, again, a super salad, an umbrella, a smell the milk, or a domino. And you can try the super salad first. Do you have an either or? Yes, on line 3, there's a super salad kind of situation, two possibilities. And then on line 4 is the negation of the first alternative. So you can infer no A, that was the other alternative, and enter it on this line. You use lines 3 and 4, so you put down those numbers. You cite the rule, disjunctive syllogism. And now you do it again. Normally, in these proofs, whenever you discover something new, you enter something new into the proof, a new line. Normally, you can immediately use it with some other line. So look at lines 5 and 1. That's an umbrella situation. You have the if, then kind of situation on line 1. And you have the if part by itself on line 5. So you can do a modus ponens. Line 6, you will enter the whole formula that is up there as the consequent of line 1. Lines 1 and 5 by modus ponens, or the umbrella, give you if B then not C. You write it down. B then not C. You use line 1 and line 5 and the rule of modus ponens. Oops. Now you just keep going and see what else you can do. You can probably see that on lines 2 and 4, there's another opportunity to do an umbrella. You have, if not D, then not C, then A. And then on line 4, you have not D. So that's another situation, like it rains, he'll bring his umbrella, and it rains. So you can infer the part that comes after the horseshoe in that formula. You will write down, if not C, then A. The justification will be line 2 and line 4. Modus ponens. If you get stuck in these proofs, if you don't know what to do next, all you have to do is just scan the lines that you have and do anything that you can do by the rules, of course. Don't just enter a formula at random because they're convenient. So apply the rule wherever, apply a rule wherever you have an opportunity to apply the rule. And if you just keep going, eventually the conclusion will sort of pop out by itself. So here you may feel that you have a lot of action here. There's quite a bit in terms of formulae and things that you're seeing. You may not know where to go, but you can just try things systematically. See if you can do a super salad, see if you can do an umbrella, see if you can do a smell the milk, and see if you can do a domino. And there's a couple of things you could do here, probably, but one thing that strikes me as a good opportunity will be lines 6 and 7. That's a domino, right? If B then not C, and then that not C hooks up with the not C at the beginning of line 7. So if B then not C, and if not C then A, entail by domino or hypothetical syllogism, they entail if B then A. You will cite 6 and 7, hypothetical syllogism. And now you're getting closer to your goal because you're shooting for not B. And here you have B. And maybe you can ask yourself, is there any way that with what I have, I can derive not B? And probably you're seeing that. If you look at lines 5 and 8, that's a smell the milk. If B then A, but not A. If the milk has gone bad, then it smells bad. But line 5, it doesn't smell bad. So it has not gone bad. These are lines 5 and 8. Horizontal. And there you have it. Now B has come out. Okay, so the idea is just keep going. Do all the things that you can do. Sometimes you'll take steps that are not really necessary, but here, like everything was necessary. There were also a couple of other routes that you could have taken. Sometimes there's more than one way to accomplish that route. But the key is to just